So picking up where we left off, the atmosphere tells a story. If we're going to talk climate change, let's talk about what's happening to our atmosphere. And let's talk about the science basis of what's going on. So measurements spanning 3 decades show that long wave, infrared radiation leaving the Earth has declined at precisely or exactly the wavelengths absorbed by the greenhouse gases of carbon dioxide, methane, and nitrous oxide, which concentrations of all three have increased since the same period of time due to human activity. Is this, though, a clear fingerprint of the enhancement of greenhouse effect due to the increase of these GHGs? Are humans actually influencing the chemical changes in the atmosphere that are changing the heat budget? So are our greenhouse gas kind of secondary effects, the breakdown of the decomposition of the fossil fuels, in relocating them into the atmosphere, is that functioning? Is that a factor in climate-related issues? Could it be as simple as just saying this is a natural cycle, Could the warming of the Earth be a natural cycle, that we are just in a warm phase of the Earth thermal change, that we're just in this kind of up and down ebb and flow of warming and cooling? If we look at some data and graphs, isn't it safe to say that doesn't the Earth have positive and negative feedback loops that keep these systems in check? Certainly the Earth has been warmer in the past, and it's definitely also been colder. So if we look at carbon dioxide, the trends here, and understand this is a very short amount of time. I don't want to make it seem like these are the long-term, deep geologic time graphs. But we're definitely seeing a positive slope. There's a trends upwards in terms of carbon dioxide atmospheric composition. And this is kind of a smaller version of the Keeling curve. And if we look at nitrous oxide, once again, we're saying that that's going up as well. And we can look at methane, CH4, we're looking at CO2, and nitrous oxide, or nitrous dioxide, however we want to call these 3 greenhouse gases. That the rate of change here, if we put these slopes together, if we're only looking at slopes here, we're seeing a very positive, we're seeing an upward climb that's at a much different rate. But don't we also have downward blips here too? So we're still kind of sorting out what it is we're looking at. So let's cover the concept that data is unemotional. Numbers do not care of who is interpreting them. Data is unemotional and it has no political venue. And that's where we kind of run into the slippery slope here. That the politics of it can muddy the water. And I think it can be deliberate. It can be even just one person looking at data or groups of people looking at data and kind of making it fit their personal agenda. But we're going to try to look past that. We're looking at numbers. We're looking from a broad range of sources. So this graph shows how well model predictions line up with observations in the real world. For example, we may not trust, we might say, oh, weather persons, they can make mistakes in telling the weather. But they can, but only within an acceptable range. And we trust that weather forecasters can tell us the weather within, say, about a week. And we trust that, even though plus or minus we give a little deviation. Well, we rely on models in climatology as well, and they can be very close predictors. They don't have to be perfect, but they can be predictors of what changes can and will occur. They do not have to be this perfect set. They can be plus or minus. They can be within a range, an acceptable range. If the weather forecaster said tomorrow is going to be cloudy and windy and it's going to reach 60 degrees, and it were cloudy and the sun came out for a couple breaks in the clouds and it reached 63 degrees and the winds kind of died out in the afternoon, you'd still be like, okay, the weather forecaster, that was close enough. It wasn't completely off. So you have to understand, they don't have to be perfect. The question becomes, who do we trust to tell the story? Do we use professional organizations? I like to think I trust NASA, NOAA, the National Oceanic and Atmospheric Administration. I look at data in the Intergovernmental Panel on Climate Change, and I think as much as anything, remember, I'm kind of trusting them and I'm trusting their data. Who do you trust? Maybe Mr. Stafford isn't the one who you have to trust on this, and I'm not saying you do. But what data do we turn to? Do we use one companies? Do we use independent data forecasters? Do we use company or organizations that have some political venue? But the idea is, who do we trust and what data do we turn to? Who's the informational outlet that we get our stuff from? Well, the science is definitely in the data. Just as carbon dioxide gets the attention as it's a direct result of the burning or the combustion of fossil fuels, But it's definitely indisputable that the amount of CO2 is increasing, and it has been increasing at a rate unprecedented in Earth's geologic history. That if we look at it simply in terms of the rate and magnitude of greenhouse gases entering the atmosphere are at a level that have never been viewed in paleo, right, ancient climate data. But maybe we still don't have enough data. That said, maybe we cannot say for certain that anthropogenics, human-caused kind of planet-changing, human-induced warming is, and maybe we don't have enough information to say that it is not occurring. I think it's important to value information and saying, I don't know. Maybe we don't have enough information. But if we can say for certain that we know it is happening, I'd say hold the phone. If we say anthropogenics very certainly is not happening, I would also say hold the phone. I don't think we necessarily have enough information, and that's my personal opinion on here. But maybe we don't have enough information. And maybe we're still seeking some information if we don't have the technology developed yet. We've mentioned the famous Keeling curve. Charles David Keeling, a director of program, measures the concentration of carbon dioxide in the atmosphere that continued from the late 50s up till now. It was studied at Mauna Loa, that's where the record comes from, right, in the middle of the Pacific, and it's definitely a positive trend, right? Carbon dioxide levels are actually today over 400 parts per million here, parts per ppms over here, parts per million. And it's in Hawaii, it's in the middle of the Pacific Ocean. And these began the long-term measurements that are based on what this program led to. So this was kind of a baseline. It's kind of an example of what long-term data studies moved into in terms of climate. But then climatologists started looking beyond just atmosphere and started studying oceans. And oceans are warming. Acoustic thermometry is a study of using sound waves to measure temperature. So scientists and oceanographers can measure how sound waves travel at different depths of the ocean water. For every 1 degree Celsius in temperature increase, the sound wave travels 4 meters per second faster. So you have these sound sources, and you can actually measure how fast they travel to different buoys or different locations. And you can actually measure through this acoustics. You can measure temperature just based on the speed, so you can find an average temperature. And as it warms, it travels faster. So the ocean surface is warming too. So now there's a few more players in the game. It's not just climatologists, it's now you have oceanographers. Now you have marine scientists that are studying this as well. So it's definitely heightened the scientific community. And so now we're talking land, air, and water temperatures are increasing. So data works by looking at trends. There is no doubt that the values are increasing, but once again, what is the cause? Is it humans or is it natural? That is key. At the end of the day, that is key. Is it a normal increase due to being in an interglacial warming phase, or is it something else in play, right? We know that the planet's warming, or average surface temperatures are warming, and sea level is increasing, and it's subtle. It's not major. These are in millimeters. These are not major values. And we can also say that snow cover over North America is decreasing. And higher latitudes are more vulnerable to temperature changes. You can see these temperature changes at further north, and the color code here, so I'm just having you focus on what's in red. These are noticeably warmer. And then the pink, kind of this peachy pink color, you're seeing them in different locations here. So higher latitudes are more vulnerable than equatorial regions, even from like a half a degree to even a 2 degree C change. But looking at paleo-climate data, right, ancient climate, we would definitely say that, well, they're linked. Temperature and carbon dioxide seem to be linked. But could temperature be driving carbon dioxide instead of carbon dioxide driving temperature? So we have a timeline back 800,000 years ago, and we can say very, very safely, well, they're definitely where we see the peaks and the valleys are consistent with the ebb and flow of carbon dioxide. And so carbon dioxide and temperature, they seem to be linked. There's definitely a timeline supporting that. So carbon dioxide and temperature, is there a connection? So this is a famous graph, and I'm not saying anything. I just want to focus on it just for a moment here. Global temperature is rising, and concentration of carbon dioxide are rising. And you know, they are. It's happening. It's not so much as to, well, are they? They are. It's what is the driver? And I'm going to bring us back to that very argument. And lastly, I just want to state the 3 major scientific organizations that I got that information from that you just witnessed is from NASA, NOAA, and the IPCC, and they all unanimously state that there's a large body of evidence that supports the conclusion that human activity, the anthropogenics, is the primary driver of recent warming. This evidence has accumulated over several decades and from hundreds of studies. First, their argument is that the atmosphere's chemistry is changing at an identical value at which increased GHGs are increasing. So, thus decreasing the amount of solar radiation leaving the Earth. The GHGs are directly related to human processes. That's what the studies are showing. That's what this set of studies are. The second line of evidence is from indirect estimates of climate change over the last 1,000 to 2,000 years and are inconsistent with past climate fluctuations, right? Tree rings, ice cores, corals, that the rise is unusual, that there's a little highlighted point of the unusual aspect of the temperature changes. And third, comparing actual climate data with models of how climate is expected to change under human influence is consistent with the rate and magnitude at which the unprecedented change has taken place. Now, I don't want to say this as a matter of fact. I don't think that's my job. I think my job is to kind of show you data that's showing that we're using models to make sense of this. And when you look at models and and the models are close, and a model tells you something, well, I don't know. Do we believe it? Who do we believe, and where do we go from here? Because your generation, what does the future hold? Your generation is going to have to sort this out. Historically, temperatures follow the carbon dioxide trend. That your generation will have to address this issue, and it will cost money.